find the solutions first. Solutions first, okay. So let's try to start with the stock of capital. So this is our equation for capital. And we substitute investment. And as we said, these two terms will cancel out. So we will have this I0, which will give us some trouble. But this is basically, this will be k minus 1 times 1 less gamma times beta. Then we'll have gamma over GDP. So we can do two things. One is, as I said, this should be a steady state model because depreciation and investment should become the same and the stock of capital should converge to a stable value. So this implies that we should have that k is equal to k minus 1 in the steady state. So this is the standard procedure we use in stock flow models, which is that we start from this equation and we set k minus 1 to be equal to k. So when we bring this to the other side of the equation, we will have k, which multiplies 1 and multiplies gamma beta. So this will be k, and then this becomes plus gamma beta k. So k minus k drop out, and we have that k will be equal to GDP over beta. But as I feared, we also have this term which will be annoying, but it's a constant, so it should not bother us too much. So this is already suggesting that for a value of I0 equal to 0, then k should not be equal to GDP as we said at the beginning, but it should be equal to, our k should be equal to GDP divided by this beta. So it should be larger than GDP. And we also have this term here, which is I0 is what we put equal to whatever, minus 25 divided by gamma times beta. So with this, we get exactly 1,000. So the capital is equal to GDP, but we cannot be so sure that this will be respected later on. So the next thing could be to try to identify the other stocks. And here, if the stock of debt stabilizes, of the government debt stabilizes, now this is, well, if it stabilizes, then net lending should be zero. And for net lending of the government to be zero, we want this to go to zero. Now, tax is equal to what we call tau multiplied by this long term. So this should be zero in the steady state. But I think that we can simplify this somewhat, because this is also equal to tau of the disposable income before taxes. So if we use this equation instead, this implies that the tax will have to be, should have tau times tax in here equal to tau times yd, so that tax is equal to tau yd divided by 1 minus tau. So here we could simplify the story and have this to be equal to yd over 1 minus tau. And this can be set so to have b in the steady state as a link with the income and expenditure. So to do that, I can bring this to here. I can drop the -1 if we're looking at the steady state, so that b will be equal to this tau times yd over 1 minus tau less g divided by rb. It's going to become a little messy now. This is, I would like this to be 0. So to this where it's 0, we would already have VH. VH, we can try to derive VH from the same steady state condition, which implies that the net lending of the private sector is 0. So YD less consumption is 0. And this implies that YD less our consumption equation gives 0. And again, dropping the -1 to look at the steady state, this becomes similar to what we have in model sim. So 1 minus C1, this is going to be a minus. So that VH can be obtained with respect to YD multiplied by 1 minus C1 over C2. But we also have this minus C0 divided by C2. Then the next step should be to substitute this into the GDP equation to try to determine GDP and YD. But are you sure you want to go through all this? It's going to be very messy unless we make some drastic simplifying assumptions. But more or less, this is how we should proceed.
VH is equal to K. VH is the total wealth.
Total private, total household wealth. Yes. And no, this is because YD depends on the stocks. So this is what makes things more complicated. Maybe it's easier if we go to the simulation first, and then we go back to the algebra. But yeah, basically, this is what we want to go through, to find YD in terms of find the link between YD and GDP. So YD is equal to WB. The WB is the fraction rho of GDP. Here we have a simplification that can be made because the dividends of banks are here, and the dividends of banks will make the interest payments disappear because these RL, RD minus 1 and these RD minus 1 will cancel out. This is because if the banks pay higher interest on deposits, they have lower profits, so they distribute less dividends. So these cancel out. And these dividends paid by firms are given by this sigma times the gross operating surplus minus the interest paid on loans. So again, if we want to simplify the model to find the solutions, let's go through what I was suggesting at the beginning. So assume sigma is equal to 1. If sigma is equal to 1, all profits are distributed and the wealth of firms is 0. And if sigma is equal to 1, things get much easier because this will cancel out. This RL minus RL will cancel out. This goes plus WB will become GDP, and we only have this tax, which I said is can be expressed as this formula relative to YD. So this simplifies like this. So bringing this tau, etc., to the left. And doing the multiplications, so this will become 1 minus tau. And this also will be multiplied by 1 minus tau. And here yd minus tau and plus tau will cancel out. So we have the simpler solution for disposable income, which allow us to express the VH not in terms of disposable income, but in terms of GDP, if this is more convenient. And the same for B. B can now be expressed in terms of GDP. So if we do this, let's see what happens. We want to substitute in here.
One minus tau.
Well, I can. Now everything is multiplied and divided by 1 minus tau. I hope we don't end up with the too simple story. So let's multiply RB in here. And now we have tau RB plus tau GDP minus G. So I can bring this to the left-hand side. And we have B is multiplying RB is multiplying B and 1 minus tau. So that B can also be expressed in terms of GDP. RB times 1 minus tau. And so where were we? Did I delete anything from here? No. Yes, there was something here.
When you rearrange.
Yes. So I think this was, yeah,
You have to bring
I deleted this, yes.
Yeah.
So bring this to the left. Equal to RB plus GDP. Can drop the minus 1 here. And this was 1 minus tau. These were all multiplied by 1 minus tau. And this was YD times 1 minus tau. So this simplified to YD. So this is what we had as YD. Now we have B. And so we can see what happens if we substitute this value of B into here. So if I'm not wrong, I can drop the 1 minus tau and also the RB, and I find this is a, no, I hope we're not doing something stupid.
I think you cannot drop the.
Yeah, I should be able to drop this. and drop this.
But that exactly there is some this RB that this was also multiplied.
So this also drops with RB. So we find that GDP plus tau GDP minus G is YD, and I don't think this doesn't really sound so right, because it's roughly saying that YD is taxes less expenditure. So I must have made a mistake somewhere.
Why did you drop 1 minus tau?
Hmm?
Why did you drop 1 minus tau?
It was the numerator.
Was not in the other side. Ah, yes, it's
Just
true.
on the
It
right-hand
was,
side.
yes, on the right-hand side, yes.
So up to here, this looked correct because now disposable income is GDP less taxes plus interest obtained from the government. But I'm not at all happy with the next substitution when we substitute what we find for RB.
We have substituted RB and B, right? Both. No.
Yeah. No, not really. So this should be coming from the equation for B, which is here. So we did RB. So let's try to do this again. It was RB times B. Yes, I think that here is where I made a mistake. So we had this equation for the government debt. So multiply both sides by RB.
Wasn't simplifying the 1 minus tau. I think that
Yes, I did not multiply G by
G
my
by 1 minus
1
tau.
minus tau. So now this should look okay. And from here, I may be interested in getting RB times B rather than B alone. So RB times B, I have to divide everything by 1 minus tau. And here this disappears. So these are the interest payments. So now this is wrong. This will be equal to this divided by RB. So let's now start again from the equation for disposable income. And we put this into RB times B. So I have to multiply this to G and to GDP to take this 1 minus tau out of my brackets. So I can delete this. And now I have the tau GDP, and this tau GDP cancel out. And the GDP is equal, the disposable income is equal to GDP less 1 minus tau times G. And this looks much more sensible to me because it's saying that given a balanced budget for the government, disposable income will be GDP less the taxes, and the taxes will be a fraction of government expenditure. Okay, so this allows me to, if I want, have VH as a function of GDP rather than disposable income. Do we need it? Yes, we need, may need it. And finally, we can go to the GDP identity. So now consumption has to be taken from our equation, which is here. Investment, we said that investment is going to be equal to the opening stock of capital times the depreciation rate. So it should be equal to the EPR times K. G is exogenous. I can take VH, the -1 from VH out. So now YD will be equal to this formula. So let me copy this down here. YD is equal to GDP so here I have this term. VH is going to be this complex formula.
There is an equal to much.
Hmm?
An equal sign to
Down here, yes.
the top of. What's in the one?
Okay, now VH is this formula here. K, also we found K with respect to GDP. And so this is it. We just need to rearrange the terms to have our multiplier. So let's try to do this without making stupid mistakes. So C1 is multiplying this term in here. And I can drop the brackets. C2 is multiplying GDP. I'll have to do it with the square bracket. And
Simplify that.
yeah, we simplify this. And here we have this DPR
think also there we can simplify the C2. Because it's a multiplication, right? So it's a C2 multiply the square brackets, multiply 1 minus C1, so we can get rid of the C2.
You are right, but
This
I
one
did,
and the one divided by C2.
but I was not expecting this. Why do we have this C0 not multiplied by C2?
Was divided by C2, we just
Yeah, all
was
this
divided
term
by C2.
here.
We simplified,
Okay.
right?
So we have this DEPR just to be multiplied also here. And everything was divided by, no, only the last term was divided by gamma times beta. Okay, so if we didn't do anything wrong, we have GDP minus C1 GDP plus 1 minus C1 times GDP plus DPR times GDP over beta. And this should be all the terms with GDP. And we are left with C0 minus C1 times 1 minus tau times, again, 1 minus tau, and with a plus, with a minus, so this becomes 1 minus tau twice times G over 1 minus C1. Then we have a minus C0 here, which cancel out with the plus C0 we had here. Then we have this DPR. We can copy this here. So we have this G here and this complicated formula for G. So let's see whether this simplifies, because this will be 1 plus all of this taking G out. And I don't think this is going to simplify, because this is, so this is 1 minus C1 plus C1. Well,
Yeah.
okay, so what do we have on the left-hand side? Yeah, please find the mistakes.
No, I think that it is 1 minus tau times 1 minus tau, it comes from the G. So the exogenous part in there is, right? So it
There's
is.
this one.
No, I think that Ricardo was about 1 minus tau multiplied by 1 minus tau, right? I think it's one is this one, exactly.
Yeah.
And the other one is this one there.
So this should be minus here. Oh, this makes more sense. Okay. And here I see that we have a lots of simplification. So it's 1 minus C1 plus 1 minus C1. And again, this doesn't really sound right, plus DPR over beta. And I guess maybe we have some signs wrong, because this was a plus GDP, C1 GDP became minus C1 GDP. Here we had plus GDP over 1 minus C1. So it should be minus 1 minus C1 GDP. and this plus DPR becomes minus DPR. So this is 1 minus C1 minus 1 plus C1 minus DPR, which makes more sense. And here for G, we have 1 has to be multiplied by 1 minus C1. So we have 1 minus C1 plus 1 minus C1 times C1 times 1 minus tau minus 1 minus tau. Everything multiplied by G and divided by 1 minus tau. Then we have this term in here. So here, let's see what we have. It's, well, let's copy this down. So this all go away. And here, we will have this term, and then we need to have tau, which multiplies 1 minus C1 times C1. Now this becomes minus 1 plus tau. So this minus 1 and the plus 1 go away. Let's go down to try to avoid making mistakes. So this now becomes 1 times C1, and this becomes plus C1 squared. And here tau, no, this I don't think will simplify. So the only thing which simplifies, I think, are these things here. And I don't know how to simplify this further. But more importantly, I don't see how, I mean, we want to have this as a negative value, otherwise GDP is going to be negative. So if this is negative, then everything is okay. Otherwise, we have made a mistake somewhere.
Yeah.
So let's also help ourselves with the simulation, because the simulation will allow us to verify if the numbers for each variable are what we expect them to be. So let's save the code at this stage, and you want to use R, as far as I understand. I would give it a try to this package, because it looks rather simple. But let's do first what you wanted to do. So I'm going to learn something on R. So we want to create the data frame first, you said?
Right. For each variable.
Mm-hmm.
And I would create this data frame also for the coefficients.
Okay, so what should I type?
The name of the variables that we want to start, maybe GDP.
Okay, so just GDP.
With assignment operator. Then numeric, because numeric. There are many ways actually to do. Marco Passerella does this always with matrices, because it allows to do scenarios with it. So every column will be a variable, then you can also add different scenarios, but we can do it simple. So numeric.
But look, the philosophy I adopt is to use the same sequence we have done to put numbers into these matrices and then find the values. So we started from a benchmark value for GDP. So what I would put is something like GDP is equal to 1,000. Then we assumed the next step was that the stock of capital would be equal to GDP. This should work, right?
Right, but first we have to create the space where to save the data.
Okay.
So exactly, so the idea is to create for every variable, so GDP, capital, investment, all of them, a numeric placeholder. So what we do usually is exactly GDP assignment, and then you type numeric, for example, 100.
After GDP.
Exactly, numeric 100. In this after 1,000. Instead of 1,000 numeric, and then 100.
In the brackets.
In the brackets. So what's the idea? Is that basically now you have GDP, which is a vector of 100 or 1,000 in this case, zeros.
No, but 1,000 should be the value, not the number of zeros.
Now first we have to create where to save the data. And then if you want to give the starting value of GDP to be equal to 1,000, then you have to say that. So what we want to do now is to have the first round. So
okay, so let's have 100 rows in our table. Yes.
We could first write comments and sections of the code that we are going to write. So I would start the comment saying we find I would just start with the number period called T 100. Next one, placeholders. Section for placeholders, that's what I was doing now. And then a line with initial value, comment initial values, where you assign the initial values to each of these placeholders.
Yeah, this.
And then a for loop, so that's what exactly will be the section simulation. The for loop.
So here we start with create placeholders.
Right. And a nice feature of R is that after the comment, you should put 4 minuses. So after create placeholder, minus, minus, minus. No, the minus sign. So like the meaning. Exactly. And then you go all the way to the right. After source, there is a button, and that's the table of content of your code. So you can navigate through. Exactly. You see, you already have a chapter. So you can navigate through your script. Maybe you have 2,000 lines, right?
Okay.
So you can create a chapter. It's very useful.
So the placeholder is created by this.
Right, exactly.
Okay.
And as Franz was suggesting, instead of typing 100 all the time, you can create another object that we can call T. Maybe T is a small letter T, because K is uppercase, which is equal to 100. So you have
like this.
So if you want to change it later and have 2,000.
So here I can have T.
You will only change it to once, exactly.
Okay.
But this is one way to do it. You can do it also in different ways. But this is, let's say, it's the simplest one.
So now I have to list all the variables, but without assigning them values.
Not yet.
Okay. So, okay, let's start from the balance sheet. And they will all be numeric T, obviously.
Right.
So VH, then we had VB. Well, VB, we said we want to avoid it for the time being. We have B, we have K. Then we have loans, and deposits. Is D a reserved word, maybe? No? Okay, so we are done with the balance sheet. So now we want the other flows. We had consumption, investment, the wage bill, profits, or public expenditure, taxes, dividends, bank dividends, disposable income, and did we use anything else? I don't think we used the net lending in specific variables, so we can really ignore them. Then we have our parameters. Parameters also need to be specified in this way. Because
It will be constant for all the periods, right?
yes,
So can also be just numbers. But you can also do it like this way. It's should work either way, right?
yeah. Now we have the interest rates: RB, RD, RL. Tax, I use tax, so also the tax rate. And the beta, sigma, C1, C2 are parameters, so they don't need to be changed. Okay. So now we have the placeholders in place. So now what? Now assign the starting values.
Right.
And how do we do that? So GDP equal to
And with the square brackets after GDP, so no GDP square brackets 1. We said 100 or 1,000.
Mhm. And then we follow the logic we adopted earlier. So K1 is equal to GDP1, right?
Yeah.
Then what did we do next? Yeah, we said the bonds were 30% of GDP. So B1 equal to 30% of GDP1. Then what else? Yeah, let's say that loans are equal to the stock of capital, deposits are equal to loans, so that the wealth of households is equal to bonds plus deposits. And this closes the balance sheet. Then we said that the wage bill is equal to what I think we called sigma rho, what we called rho times GDP. So how do I define a parameter that is not going to change?
You can just type the name of the parameter.
So row equal to,
Exactly. So assign that to be what
0.8. So we have the WB1 is equal to row times GDP1. And did we create a space for YB? Yes. Then GOS1 is equal to GDP1 less WB1. These interest payments do not need to be computed other than for the disposable income. So we had taxes, and we need a parameter that we call tau. And we put tau equal to what, to 20%? Yes, 20%. So the tax is equal to tau times GDP. Then yes, we have to define dividends and bank dividends. So we said dividends are equal to, this may be tricky, the profits less L times L. But I think we did not define RL yet. Now we can define these here because they were all exogenous. So we said RD is going to be equal to 0.01, RB going to be equal to 0.02, and RL to 0.03. So this now should work.
I think we need just the placeholder for the interest payments. If we define them.
Which interest payments? This product? This would be the interest payments.
You want to compute them all the time, like multiplication.
Yeah.
Okay.
So div B would be equal to RL1 times L1 minus RD1 times D1. And we have, yeah, we have D1. Let me check whether everything works. Yeah, everything seems to work smoothly. So now we should have everything to define disposable income as let's use the notation I have here. So it's going to be YB1. Can I have spaces here, or should I eliminate the spaces?
Both either way. But I think BB is in more case letters.
You're right. RD1 times D1 plus RB1 times B1 less tax 1. plus D1 plus DB1. Then what? We need to, I think we have covered this. Let's have K, but this is an equation, it's not the definition of K, but we need to create the parameter, the EPR, which would equal to 10%. These are all being defined. And I think we have defined all the variables. So now we have to specify the equations.
Then we do the for loop now. So as we did last time, for one, for every I, open parenthesis, I.
For one,
No, for open parenthesis, I, in, space, in, 1 to T.
1 to T,
2 to T. So from
2 to T, and then curly brackets.
Braces, yeah. And then we can start with the iteration. So now another for loop. For open parentheses, iterations, or whatever terminology you might prefer.
Iterations.
Yeah, iter, it's the same, it just has to be a name.
Okay.
In, exactly, just a name for an index. Iteration is more clear. In from 1 to, or let's say 10, or depends. If the model is really large, you have to iterate many times to find the convergent solution. This is a smaller one. I don't know, maybe 10 is already enough. I mean, the more you iterate, the longer it will take, of course.
Okay.
And then another curly braces, opening and closing, and then we can start with the equations. And that's it.
Okay. Now, as I said, here it would be better to have the triangularization of the model. So let me use 15 minutes to do this in eViews, hoping it's not going to take us longer than 15 minutes. So let's create a work file. And define a model simple. And this will be the equation of our models. So we'll append. Okay. Oh, yes, I cannot use D in here. I need to use something like dep for deposits.
Because it's reserved.
Yes, so it means a time difference. And D is here and should be Should not find it. Yes, it's also in here. Okay. Okay, so this gives me the triangularization that EViews has found. So the first equation should be for the dividends of banks. Then all these equations must be solved simultaneously. And after that, we have the recursive equations at the bottom. So we can use this to start from div B here. So this will be div B at time I.
But exactly, so these iterations, I think that avoids this the triangularizations, as I understand. So the fact that you iterate allow you to write the equations in whatever order you like, because you are going to repeat them over and over again, so 10 times in this case. So you don't have to write them in order.
No, this is not how it works.
Okay.
Because basically what the software does for simultaneous equations, they assign a starting value, then they verify if by substitution the end value is close enough to the starting value. If not, they repeat the iteration. Now, if you have strong feedbacks, you may not have convergence towards the starting value. So the triangularization helps, to eliminate some iterations and increase the speed and reduce the possibility that you never converge. But anyway, yeah, it should be. Okay, so now this should be the dividends of banks are given by the interest on loans times the stock of loans of the previous period. So this would be I minus 1.
Yeah.
And then the interest on deposits times the stock of deposits of the previous period. Then the next can be the investment equation. And this was we relied on additional parameters, so we need to specify them somewhere. So we had I think that I0 should be specified as a numeric, and I0 was minus 25, if I remember correctly. Yes.
But if you write like that, you don't have to create the placeholder, because what you're doing now is to rewrite the object.
Oh yes, I wanted to do I01 to be equal to minus 25. Then we had other parameters, gamma and beta, and this should not change. So gamma may be a reserved word.
No, I don't think so.
So gamma, what value did we give to gamma is 0 to 5. And beta was 0.9.
C0?
Hmm?
Did we define C0?
No, not yet. Let me write the equation for I first. So it was I0 I plus gamma times GDPI, sorry, gamma, which multiplies GDPI less beta times K I minus 1 plus DPR times K at I minus 1. Okay. Then the next equation would be WB. WBI will be equal to, it was rho, which is constant, times GDPI. Then we had Gauss surplus, gross operating surplus equal to GDPI less WBI. Then the dividends here were GOSI less RLI times LI minus 1. Then taxes. Here it's usually simpler to use this long story, because if we use YD plus tax and simplify and tax equal tau y times YD over 1 minus tau, and then we have an equation for YD which depends on tax, there will be an additional simultaneity, while if I use this definition, there is no simultaneity in computing tax and YD, so this is better for my purpose. Okay, so this will be tau, which is a parameter, WBI, RDI, WB has to be lowercase. This is DI minus 1. RBI, BI minus 1. Div I, div BI. Okay. Then consumption. And here we have to define C0. So again, let's have C0 also as a vector. And we found it should be 57.8, while C1, where fixed parameters 0.75, and C2 was 5%.
Should not be C01.
Thank you. This will be C0I plus C1 times YDI I plus C2 times VH I minus 1. And this is it. Then we have YD. So YDI is equal to WBI plus RDI times DI minus 1 plus RBI times BI minus 1 plus minus tax I plus div I, think plus div B. Okay. Next is GDP. Equal to consumption plus investment plus government expenditure. Then YDB. At YDB, I think we don't need. NLH, NLB, NLG, we don't need. We need K. So Ki is equal to the previous value multiplied by 1 less the PR plus I. Are we going to have a problem to having investment as the same letter as the our loop index?
Yes, we will. Yeah.
Okay, so let's call this in for
No,
investment.
in it's the reserve.
In
That
with
is
reserve.
The in. INV.
INV is inverse, is a reserved word.
IN is reserved. INV is not reserved.
INV. Okay, INV. We forgot to define this. Yeah, we forgot to the starting values of the components of GDP. We want to have CO1. Yeah, we should have completed this process actually, but we didn't. So here CO1 is given by C01 plus C1 times YD1 plus C2 times BH1, and in 1 should be what I was going to type, didn't type yet.
Though I believe that it's not necessary to define all these variable at times 1 if you are not going to use the length variable of this variable in the loop. So in the loop, so the idea is that, you know, the second round in the loop can be considered the first one. We have to set up the first value if from round 2 we are going to use some exogenous, so some lagged endogenous variable. or some lagged variables for interest payments or whatever it is. Otherwise, it can be 0, and the second round is going to be our first one.
Yeah, but we want to have valid values for the exogenous in the first round and for the parameters.
Yeah.
They won't, I mean, they are not valid. You find them like this, right? Because the general stock in the first round.
No, this is just starting values.
Yeah.
Then when we have the,
This should work really, because if we have defined already all of this.
Yes.
You can run up to line 33 and you will see
yes.
if it works.
So now I wanted to add the K. We didn't have I. Don't know why we didn't have. Oh yeah, here it is.
Yeah.
We did have I. So you say, should we run everything up to here?
Yeah, but you have to change. No, only up to 53. Just to test that it's working. Yeah. And it's working. Yeah.
Okay.
Or at least we have a message. I don't know.
So K is also now defined. We need B.
We have also to change investment in the loop, in the body of the loop, from I to in.
Yes. In. And also in here. And in GDP. Okay. Now we need stock of bonds. Plus G less plus RP times B minus 1 less taxes then VH minus 1 plus YD less consumption loans, and we said that loans are the difference between investment and retained profits, which were GOS less RL times L minus 1 less dividends VB is 0 and deposits, we wanted deposits to be equal to wealth less bonds, right? Yes. Okay, so we're finished.
Just one question, I think I'm missing. Why didn't you write all the equations? Or not, why didn't you write NHL and
Because we've done without these variables in every other equation. So they can be useful to give us a synthetic measure, and actually it's a good idea if we do that. But to have them or not would not change the model solutions. Now, what we need to do in here is also to have these intercepts. So what we called I0 should be equal to its previous value, right? Because we only defined the first value for I0. Yeah, and C0 should be the same.
And the interest rates as well. That's fine.
Yeah, all the exogenous.
All the exactly, G exactly, yeah.
Or, I mean, if you don't want to change them, then you just define them as a.
Yeah, as a constant, as a parameter, yeah, that would be also.
Now, in principle, you will want to change one of them at one point. So let's,
But in this way, it allows you to change them from one point in time. So
Yeah, it's good. It's good to have them.
do we need something else? Maybe not, hopefully not. So can we try to solve this? Let me save this to our folder. Depth.
deposits.
Deposits. But we do have L, don't we? Oh yes, because depth was D. So I actually now have D and depth, which is not good. Okay, so I've deleted. I can use D.
Yeah, and then change it in the body of the loop.
So I only need to delete depth in here and have D. So it worked. And now how do we look at the solutions such as GDP should give me the value? Nicely go negative. And what about VH? VH goes very negative. K goes very negative. But G is 0. Is G equal to 0? There's no doubt everything goes negative if G is 0. We did not give a value to G. Okay, so G was 200.
The index. But I think also in the loop, we have to define the G.
No, it was defined to be equal to its previous value in here.
Okay.
So let's now look at K. Now it's much better. And GDP, but this is not a steady state, it's growing. So can we plot a ratio or should we, so let's define a new variable KR for the ratio of K to G. So I guess I could write something like this, can't I? Okay, so let's look at KR. So I can plot KR.
Yeah.
So it is converging to a steady state. So this is reassuring.
At least the ratio.
And the steady state is close to 973, which is more or less what we had before. Let's look at investment, which is we called in. And in is not going to 0. We should look at investment and the depreciation, or look at K. Let's have net investment equal to investment less DPR times K, even though this is not exactly correct. And this is going slowly towards 0. But very slowly, still very far from 0. Now we want, the model should go to steady state when this goes to 0.
We
Yes.
can try with 1,000 rounds and see what happens.
Mhm.
The way you define investment in line 54, that's different, right, to the actual definition.
Yes.
That might be a shock. Might present a shock.
Yeah, this is why this model does not start exactly from the right solution, because we have this approximation in both consumption and investment. Yeah, what we hope is that these converge to stable values so that we can try to have stable values.
We can test it. You just have to change from 100 to 1,000 at the top.
But we could do something different. I could, so we know that investment should converge to 0. So I could also try what happens with this. So let's look at what happens now. But it's always trying to converge, but not converging yet. Hmm? Now we could try to have the model help us with the algebra. So for instance, we could define the ratio of disposable income to GDP and check whether this seems to be converging to a value. Now, the algebra we did was suggesting that YD should be converging to GDP minus 1 minus tau times G. So I could define a YD star and compute it as GDP less 1 minus tau times G. And if I plot, I think I can plot YD. How do I plot it with a line?
Yeah, you have to
Type
L equal
L.
open square bracket, the quotation marks L.
And then I want lines
You can add another one.
and have YD star.
Yeah.
but they're not converge. I thought they would converge to some stable value, but they're not. Also, GDP is not converging to a stable value. And what about K? So K is not converging to a stable value. So this is must be the case that what I call net investment equal to investment less depreciation is not converging to zero. So this makes the stock of capital grow forever. And our algebra was suggesting what? That but our algebra was based on the assumption that the stock of capital would converge. So all of our algebra was based on the idea that we were on a steady state, but the model is not on a steady state.
Yeah. But could it be that this is because of interest payments? So interest is fueling, for example, the government was in deficit. That's what we saw also in the Excel matrix this morning. And has to go into debt. And once it has to into debt, has to also to pay interest
Yes.
on the debt issue. And this interest goes to the consumption of the households because
Yes.
or to the banks and then the consumption of the households.
Yes.
Keeping one steps. And this will feed consumption, which feeds the GDP, and therefore
We can check this. So let's add the definition of government deficit.
this is also what we were discussing with France and also that these interest payments work always as a drivers of growth.
But only the best continuous financing, like that, then that's why.
Yeah, exactly. Right.
That converts. Okay.
But maybe in a ratio converges, not
The stock of debt should converge to then.
how is it possible? In every period, you have additional deficit and then additional because of interest payments that are growing and growing and growing. So the deficit is.
This will be considered in the disposable income, and this will be consumed.
And this would
This will increase GDP and increase revenues and directly.
So in ratio, that GDP ratio should converge. Or the stock of.
No, the GDP is not growing. The GDP.
But isn't it because of investment? That it, I mean, it will be, I'm sorry, yeah. GDP will be always larger than gamma times the capital stock of the previous year. So,
Yeah, I think that this is where the problems may lie. I think that you are on the right track.
Isn't this type of equation like type of
Look, I told you from the beginning that
therefore, if you start already with the GDP, as we define it above the level of capital stock of the previous year, you are always going to have a rise in investment.
let's follow my intuition that was that this constant in the investment and consumption equation create trouble. So let's then at 0 and see what happens. So let's plot the government deficit. Now it's not 0. Let's plot K. This K is still increasing. So it's not sufficient to, let's set the K ratio as K over GDP. But this is converging. There's no easy way to compute the change in the stock of capital, is it?
Yeah, the growth rate.
No, the difference, time difference.
Yeah, of course. You can just create another variable which is Ki minus Ki minus 1
Okay. And I have to include it into the simulation.
into the and create also I think a new placeholder like K
Mhm.
diff.
But here I cannot use the leg.
You can try to do it also there.
So can I,
Try to diff K. Let's see what happens.
okay, so what I wanted to have is the a new variable called depreciation equal to the parameter times K minus 1, but I cannot write K minus 1 in
No,
here.
in this way, no.
Can I write leg?
Leg, although I think we should load the package where this leg function. Yeah, but
This requires a time series.
exactly. So could you please try to load the dplyr package? So with the library function, you just type library and dplyr. Yeah, this one. Okay, and then exactly, see, because this is rewriting
Mhm.
the leg function.
And now what?
And now what you were trying to do before.
So I wanted to look at the depreciation. Well, I wanted to define depreciation as the EPR times the leg of capital.
Yeah,
So
try to leg.
yes, K 1.
Yeah.
Okay. So now I can plot in. And then add depreciation. So there is a constant difference, it looks to me, between the two. Let's call this in D equal to in less depreciation. Yeah, this is going to 0, but so slowly. And you were saying that we could have this run for 10,000 times, and it should eventually go to a steady state.
Yeah.
Okay. Let's look at well, the same thing I just did. No, this.
Because we didn't want the.
This did not stop from falling, kept falling.
It's not converging to a.
What did you saw?
Yes.
Try the iterations. Are they still the same? Maybe they are.
Then maybe we need more iterations then.
Maybe it's
Because you're saying we're finding a local solution and not a global solution.
Maybe.
Yeah, but I don't think this is the problem.
We can try to just increase the number of iterations and see from 10 to 100. I don't know.
But as I told you, I don't think that this is the main problem. No, now this goes negative.
So if it's changing things, then at least we need more. We need a high.
No, the iterations are relevant only if you are not converging to a solution. So
I would think that if you increase the number of iterations and you have very different numbers, then the initial number of iterations are not enough.
But before we were going to 1,000, now to 100 again. So the numbers might be different also because of the different. That's why the number
Mhm.
is really different. Yeah.
okay, well, let's have a break now, and then
Can you say this? I think the nodes are not in the cloud. The drive.
this simple.r is in the. No, I saved everything as simple model in the folder. This should be the shared folder. And you have simple.r, simple model txt, and simple model xls with the spreadsheet. So you have everything.
Yeah.
So let me check what happens if I also.
I think like this is what she said, it works. You will decide.
What happened?
Convert.
Doing what?
C1 and C2 equal to 0.
Yeah, its consumption is 0.
Yeah.
Then yes. We have the
Well, no, it's constant. C.
That grows according to GDP also, right?
Yeah. It's always 30%.
You always say.
Yeah.
why is sigma not defined? Oh, because we have dropped sigma from the.
Always for every period.
No, shouldn't be.
Shouldn't be. We should go. You have the model run in computer. Can you try to do the plot of the ratio?
And in EViews, it would not get to convergence. So this is a sign of some serious problem. So let's check.
Without investment.
There must be some complete feedback that happens somewhere, maybe in the closure of the balance sheet, because it is not able to find any solution. So let me take out the equation for investment. I is not defined.
Yeah.
In is L yeah, even if I take out the investment equation, there is no convergence. So I must have made something stupid in closing the accounting. And what we've done is to define B, actually deposits being given by wealth minus bonds. So let's see if now this works. No, it's not this one. But this is strange because now the only feedbacks are through consumption and GDP and disposable income. So
Where do you read this?
hmm?
How do you read this from this table?
Here, this is the triangularization. So the simultaneous equations are consumption, GDP, wage bill, profits, dividends, taxes, disposable income. And the only contemporaneous feedback is from this equation here. So one brutal way to go, as I suggested earlier, is to reduce the simultaneity. Now, if I reduce the simultaneity, now this should be completely recursive. And the only thing is here, this is the tax. And oh, but this is where I have a problem. Don't know whether the problem is also in R, but I don't think so. I did a copy and paste. Yeah, I did a copy and paste from my text file. Now this solves easily. And the system is completely recursive. But let's see whether we don't get a steady state. Well, actually, we tend to a steady state for a much higher value. So what we can do is to look at the stock flow ratios at steady state. And let's look at the stock of bonds relative to GDP. This is not converging at all. So there is something weird. And this means that the deposits are getting negative. No, they're getting much larger than wealth. So this is crazy. So the government is going into a surplus.
When you're not considering investment, no?
No, investment is constant. So the stock of capital is constant.
There's no problem with loans. No.
No. So now that we have fixed the problem with the convergence, let's try to bring this back. But I think it's not going to change that much. So the point is, we don't have a rule for bonds to converge to some stable value. And somehow they collapse. Hmm?
The government deficit.
Yeah, the government deficit is turning into a surplus.
Yeah.
And it's tending to converge to a negative ratio to GDP. But this must be the outcome of our parameters for the consumption function. Because here, basically, since there is no investment, the stock of, well, why is this growing so much? Oh, I see where the problem lies. This is something I should have remembered. Now, when you have depreciation, you don't want to distribute the profits that needs to finance depreciation. And this is where the problem lies. So basically, what we have assumed is that firms will distribute everything to dividends of their profits, but they have to pay for depreciation. So they borrow the amount they need to pay for depreciation, and this doesn't make sense. So we need to change the assumption, saying that
It would make sense. Why it doesn't make sense?
no, because the idea is that you want to achieve a stable capital output ratio. To do that, you need to keep the capital at current performance. You want to pay for depreciation first,
Okay.
and then distribute the dividends. So what we should do is to subtract depreciation from profits before we distribute the dividends. So I don't think we need this WDB, which is not in the R file. I think it's present only here and here. Okay, let's keep it and let's add it to the variables we are using in here. So YDB and will be initialized to be equal to whatever the level of investment. And we want to change the model so that this is net of depreciation, and depreciation is what we call the EPR times K minus 1. So this will be the retained profits. And here, this now should be correct. And let's see what happens. So let's see what happens first in E-views. So here we deduct depreciation on the opening stock of capital, and the dividends, the dividends should be paid on this less depreciation. And I think everything else should be okay. Sorry. So now let's look at K first. K is constant. This is still growing though. So there still is some problem. But this is stabilizing in nominal terms. Why is this still growing? Because this is 0. Oh, yes.
But you basically muted.
No, I did another stupid thing. So the point is retained profits must be equal to depreciation. So that is the source of finance for investment. So we don't want to do this in here. But when we compute the dividends, we want to keep this out. So let's see if now this is okay. Sorry. Okay, now this is depreciation, and this should be the same. So the stock of capital should be the same. And let's look at the stock of loans. Stock of loans now is not changing. So the stock of deposits should also not be changing. So the stock of wealth should not be changing. Instead, it is changing.
Yes.
So we still have an inconsistency somewhere. And it must be also in the bonds. No, but this is, it's good that this has popped up, because I fought for some time on the story of the depreciation and the profits, and you want to know how it works. So the point is that in given the parameters, the debt to GDP stabilizes at about 3.6% of GDP. And therefore, the stock of wealth, since deposits and loans are not changing, the stock of wealth is stabilizing at the same level. So we should have values of the stocks relative to GDP, which are coherent with this long-term solution. And I think we also needed to change what we have done here to derive the steady state solution, because it contains a mistake. And this is why we also made a mistake down there. So if we, let's say that we take the value at which wealth is converging relative to GDP, this is about 4 something, 4.2. And I guess bonds will be converging to a similar value. And let's try to change these values so that this is 3.7 times GDP, and deposits are equal to the stock of capital. So let's see whether this now converges more quickly. It's converging more quickly, but it's not yet, this has not stabilized yet. I guess the stock of wealth will show a similar path. Yeah. So this should depend on the parameters in the consumption equation. So let's try to see what happens if we change these values here, increasing the consumption out of wealth. Now this is converging towards a smaller value. So let's start, let's look at B as well. So this is very much a trial and error procedure. So now this is converging towards 1.65, because the long run solution will depend now crucially only on the parameters in the consumption equation. Yeah, now it's converging rather quickly to a stable, steady state at 1.65. Yeah.
To increase tau and the tax rate.
The tax rate
Yeah, maybe it will convert
more quickly.
and that's.
And this is 2.14. It still needs to start from a smaller value, and then it's always converging to the same values now. So you say if we increase the tax rate let's put it, I thought it was 20%. Let's put it at 20%. Yeah, now it's pretty stable.
Yeah.
It's still positive, but it's converging more quickly to 1.355. And wealth should still be given by B plus dep. But now this is changing. So it's also depending on the starting value, maybe. It's not 879.
There is more change.
Yes, it's in a small range. 879 is still the value at which this is converging. Let's look at GDP. So now GDP has achieved a stable value. It's at 1,070. So let's see. All interest rates are 0 here. And
Basically, this is the same model.
roughly, yeah.
Roughly, yeah. Yeah, true. The dividends.
Yeah, now this is stable. Starts is 1077 and 107, which is what we used. So should be now a steady state model. That's a steady state model. So, yeah.
Just changing the parameters.
Yeah, well, everything depends on these parameters. So let's replicate this in R. So what we have done is to change the C2 parameter to 10% and the tau to 20%. And the starting value for GDP at 1070, I think.
Yeah.
And the B at 879, 87% of GDP. Okay, so now if I plot still not 1070. What else did we change? Did we change the equations here?
Oh, you also changed
The dividends, yeah, where the depreciation.
Yes.
Or this discussion that we did about.
Yes,
dividend
here
payments
we
and
need to subtract the depreciation rate times the opening stock of capital. Yeah, now it's as we get it in e-views. Okay, so we can now try to work out how this should change when we have fixed this this stuff.
Maybe we can try to shock one variable.
Yes.
Exogenous one parameter.
Yes, we can try to, here we can shock the investment levels, for instance. So let me do a simple dot solve, and then we can change this scenario and override whatever. Here I is exogenous for the time being, and so I can shock investment. So forgot to have simple dot override. So we can look now at GDP and this is what you get. You can look
So
at
there's a
the
multiplier of 2.5.
yes. You don't have inputs here. The government deficit is reduced and then goes back to wherever it was at 0. Now, the interesting thing is to try to bring back the investment equation. Because now what we had, and this is how the model, the simulation can help us work out a feasible investment equation. So now, but actually in here, the stock of capital, the stock of capital is growing with investment. Investment is constant but equal to depreciation. So the stock of capital is constant. Now, we wanted to have this equation here. So what if, what would be beta times k minus 1? I don't know why this is changing. So I thought that the stock of capital was absolutely constant, but it looks like it is not. No, it is not completely constant.
Because it's depreciating.
But DPR is, oh yes, because I put it at 1070 now. If I put it at 1000, and now it is 1000 is constant. So looking at beta times this one, we have 900. GDP less this beta would be in the range of 170. So this plus the depreciation of the opening stock of capital is in the order of 270. So with these parameters, total investment is larger than what we want. So in the steady state, we want GDP minus beta k minus 1 to be 0, so that this is not increasing with respect to the depreciation. So we want our beta to be equal to the GDP over the opening stock of capital. So if the two are different, yeah, this should converge to 1.07. So let's have this would imply gamma equal to 1. So if we keep so right now this is 1.07 and we want I don't know if you're following me. I want to have a value of gamma smaller than 1, but such that when I multiply this by gamma, I get 0 at the beginning. So if beta is 1.07, this should be feasible. And my gamma can be whatever, since what I have in the brackets should be 0. So let's check whether this now works. With I0 equal to 0, I can try to endogenize investment in this way. But this is saying that I have a problem of convergence. And indeed, investments are going hugely negative. And this is because they are smaller than depreciation at the beginning. So the stock of capital will be falling and GDP will be falling. So this has not worked. Yeah, this is slightly negative and gets huge very quickly. And I think that with the depreciation, this also becomes worse. Yes. So this is not a proper investment equation.
If you add both the GDP and capital, with GDP minus 1, capital minus.
Well, what is usually done in post-Keynesian models is that either instead of having the level of investment being specified, you have the growth rate of the stock of capital. So if we want to do that, so usually you have an equation like the growth rate, let's call this GK of the stock of capital will depend on the utilization rate. So let's say that this is this GDP minus beta K minus 1. What can be the utilization rate would be GDP over K. So what if we have sorry, let's go back to our solution with exogenous investment. Now I don't understand what's happening here.
The short is there.
Yeah, but this should not really matter. Okay, now this is fine. So what was happening here, I don't really know. Anyway. Now this is 1.07. And how do we want to write our growth of the stock of capital? So starting from here, what we would do is to divide everything by the opening stock of capital. So forgetting about I0, this would look like something like gamma times GDP over K minus 1 minus beta plus the depreciation rate. But this please check that I'm not writing stupid things because I'm also tired. So if this is the growth rate, then this should be investment. But let's see whether this works. No, the values are negative.
Difference investments, fund investments.
I'm sorry?
In your last equation, I is equal to GK and K. Is that not the equation for capital stock rather than investment?
You are perfectly right. So yeah, you're perfectly right. This is the equation for the stock of capital. So if I want investment, which is the change in the stock of capital, I need to subtract k minus 1 to both sides, which means I get this. So this should be investment. Okay. Still, there's some trouble in this equation. Now this is exploding. So the values I've chosen are too large. So let's look at this gamma. So this starts with a huge number. And what is gamma in here? 0.5.
But when you
Yeah,
define
0.5 is too high. Hmm? Now this should be a growth rate. So 0.5 is not in the right range. So what we have for GDP over K at the beginning is 1. So what we want to achieve is a growth rate of 0. So 0.5 is a 50% growth rate. So it doesn't make sense. And what is beta? Beta is 107. It's also huge. So if we have that this is something like 0.01, let's see what should be the implication for beta, because now we have something like 0.01. This is the depreciation rate was 10%. I don't remember. 10%. So let's have beta at 10% as well, and let's see what happens. Well, it has solved at least. But this is growing, so this is going to 100. GDP is becoming 100 times the stock of capital. So the stock of capital is going to 0. No, it's growing at 10%, which should be the depreciation rate. So I think we have
0.
No, I think we still have something stupid with the depreciation rate in here. So if this goes to 100, this is 10%, and these two tends to offset each other. And it doesn't really work. Maybe I have to add the depreciation here. So let's see whether, no, this is still going to nowhere. It's funny though. Yeah, now it's getting slightly better. The GDP to capital ratio is not going to the sky. But the growth rate of the stock of capital is not exactly 0 as I would like it to be in order to have a stationary state. So the other possibility is that we try to get a stationary growth model, and a stationary growth model would require to have the other exogenous variables grow at the same rate as the stock of capital. So here we have government expenditure. So instead of keeping government expenditure constant, we want to raise it, to have it grow at the same rate as the stock of capital. But maybe if we play around a little bit more with this, it will we'll get to somewhere. But it will take a little time. So now K. It is not stabilizing. Well, yeah, well, the trouble is we need to find an investment equation which is stable relative to the rest of the model. So far, if we keep investment exogenous, the models seem to work well. I don't know why I call this program R. So let me check that this is still the case. Yes, we now have a steady state model, but without the investment. Okay, so should we give it another try tomorrow morning, this investment equation? Because then one could start from here and try, let's say, checking whether income distribution matters. So here we have an exogenous income distribution, but we could change the assumption, have that, let's say, part of profits are kept for financing investment. See what happens. So there are several exercises we could do. Yeah, now the government deficit is at 0. So household saving is 0. Everything is stationary. Okay. So what I'll try to do before we meet again is to go through my algebra with the simplified model without investment and get the long run solutions. so that we can try to use them for finding a good investment equation. And this is one way to solve our problems. Okay, so is it okay if we stop here?
It was a lot of information, a lot of things.